All right, for this video, we are going to start to develop the unit circle. And the unit circle plays a massive role in being able to figure out stuff in trigonometry. um, the key things that we're going to need date back to when we talked about the special right triangles, your 45, 45, 90, and your 30, 60, 90 right triangles, as well as the basic understanding of um, the arc length or the circumference around the outside of a circle. All right, and we've already developed some of this stuff before, but we're going to go through it, some of it again, and we're going to build upon it so you can see what's going on. All right, so in general, the unit circle, the word unit in mathematics and sciences typically relates to something having one or a single unit. Therefore, the unit circle is a circle. That is horrible. A circle with a radius of 1. That is literally what a unit circle is. So every one of the rays that you see coming out of this circle have a radius of 1 or a length of 1. So what we're going to do is we're going to build the circle around some of the important angle measures and radians. And all of them, for the most part, are going to stem from those special right triangles that we talked about. Now, I will tell you that this specific circle that you see here is not really to scale because those arrows are supposed to be a little bit more uniform the way they are. I'll explain that as we get a little bit further because I think the sketches and drawings and the stuff that we do a little bit later are a little better. But the idea is, let's start off with some basics. We know that if we start our initial side on the positive x-axis, that would be 0 degrees. We know that if we were to go all the way around the circle, that would be 360 degrees. So 0 and 360 degrees lie in exactly the same place. They just would be coterminal angles. That means that half of the circle is 180 degrees. Again, we have already talked about all this. That means that 1/4 of the circle, because that would be half of the 180, would be 90 degrees. And that should really make sense. Man, I'm just having a hard time sketching these numbers right now. Because that would create that right angle right there. I'm going to erase that so you don't have to write it. But that would be your right angle right there. And then if you think about it, if I go from 0 to 90 for 1/4 of the circle, and if I add another 90, it's 180. The one down at the bottom here would just be adding another 90, which would be 270. And then if you add that extra 90, that would get you all the way back to the 360. So those are the what are called quadrant angles. I'm just going to call them that. It's a different word. I just can't spit it out for right now. Those are the angles that are created by the x and the y axis. The other special angles, again, that we talked about are going to be based upon 30, 60, and 45 degrees. So the one that is right here is supposed to be a 30-degree angle. So basically from here to here would be 30. The one that is here is supposed to be your 45-degree angle. And I keep saying supposed to be just because of the fact that it's not really drawn to the right scale. And then the one that's up here is supposed to be a 60-degree angle. It's actually more like over here. But I don't know why I got sketched the way it is. But we're going to focus on this first quadrant. Quadrant 1 up here first. Because if we can get the stuff in quadrant 1, we can get everything else that we need to for the entire circle. But those are the basics. Those are the ones that we're going to need. Those are the special angles that you're going to have from your unit circle. There are an infinite number of angles that you can draw, but those are the ones that are going to help us out the most. So in order to do this, we're going to develop one at a time. We're going to develop the 45, 45, 90 right triangle. So in this case, this angle, this theta down here is 45 degrees. Which means, because they got a right angle over here in the right-hand corner, that this angle up here is also 45 degrees, which makes it a 45, 45, 90 right triangle. In order to develop this, what we need is we talked about this before with the 45, 45, 90, and 30, 60, 90. You only need one side. And I already have one side every single time we do this because I always know the radius, which represents the hypotenuse here, is 1. So now I have a side of the right triangle. Well, if you remember the concept, each one of these sides right here has the same length. Okay, that's what that little mark meant. They have the same length. In order to get from one of the legs to the hypotenuse, you would take a leg and you would multiply it by the square root of 2. But this time instead, I have the hypotenuse. So I'm actually going to take the hypotenuse and divide the hypotenuse by the square root of 2 in order to get a leg. So this would be 1 divided by the square root of 2, which makes this 1 divided by the square root of 2 because they have to be the same. Okay, well that's really nice because getting that is basically going to get us an x and a y coordinate. So the point on the circle up here is going to be the x value, which is in that direction, and the y value, which is in that direction. Well, they happen to be exactly the same. Now, if you can leave it as 1 divided by the square root of 2, I'm perfectly fine with that. If you choose to rationalize it, which is a way you're going to see most of these things done, rationalizing 1 divided by the square root of 2 would be multiplying the top and bottom by the square root of 2, which would get you the square root of 2 over 2. Okay, again, this is probably the way you're going to see it mostly. I am perfectly fine if it's unrationalized for now, unless, of course, something says to rationalize it. So we're going to write this ordered pair as the square root of 2 over the square root of 2. Because again, what you have to think of is this is basically an xy coordinate plane where this right here represents your center, or 0, 0. So the x value in this direction was 1 over the square root of 2. The y value in that direction was 1 over the square root of 2, which again, rationalized is square root of 2 over 2. So it's the square root of 2 over the square root of 2. I'm sorry, it's the square root of 2 over 2. I knew I said that wrong, which is why I paused. Square root of 2 over 2. But it's that case for both x and y. All right, so that develops that specific point. On the next one, we're actually going to develop the 30, 60, 90. And you're actually going to do that in 2 different ways. So the first one, this one right here, you should be able to tell just by looking at that, it's a relatively small angle. That's your 30-degree angle, which of course makes that one up there 60. And again, remember what we already have is we already have the hypotenuse. That's 1. Now the relationship between the hypotenuse and the short side of a 30, 60, 90 right triangle is the hypotenuse is double the short side, or another way to say that is the short side is half of the hypotenuse. Well, half of 1 is half. So the length here in the y direction is 1/2. Which makes the x direction, remember you take the short side and you multiply that by the square root of 3, the square root of 3 over 2. So my ordered pair, now this time it does matter, is the x always comes first, so it's the square root of 3 over 2, and the y value is 1/2. All right, so now if you really think about this, and I'm going to do some erasing just because of the fact that it's going to get a little bit messy. The other triangle that we have, well, that's a 60-degree angle. So I'm going to erase what I have. I'm going to leave the ordered pair there. But now this triangle, oops, it's not supposed to be in green. It's still in green. What is going on? There we go. That length is still your radius, it's 1. But in this case, this angle is now my 60-degree angle, which makes this one up here my 30. Just having a really hard time right now. There we go. And here's your right angle. So now this time, the short side is actually the one on the bottom. It's the x-axis one, which makes that distance 1/2. So that distance right there is 1/2. And that makes the long side the square root of 3 over 2. because I would multiply the 1/2 times the square root of 3, and I would get the square root of 3 over 2. So now this time the x is 1/2, where the y is the square root of 3 over 2. And the one thing that I hope you are going to start to recognize is that your 30 and 60 degree angles are always going to have the same ordered pair, but reversed. So you can obviously see that the 1/2 and the square root of 3 over 2 are in both of them. One of them is the x, one of them is the y. It just happens to be that in the other triangle, they are reversed. They flip. Not flip over, but they switch. So that is developing those specific ordered pairs based upon the 30, 60, 90 and the 45, 45, 90 right triangles. The biggest thing, again, is that the radius is always 1, so you can always figure out these specific ones. All right, so how is that going to incorporate into the whole unit circle? Well, there's going to be a bunch of symmetry here. So we're going to develop that on the next page. Some of this, again, we already know. The extra blanks that are in here are for your radian measures. So let's remember that 1 revolution is 360 degrees, which is also 2 pi in terms of radians. And again, we've already done some of this. So 0 would be 0 pi radians because we haven't gone anywhere. 360 would be 2 pi radians. If we go half of the circle over to 180, well, half of the circle would be pi over 2. I'm sorry, pi radians because it's half of pi. The 90 degree angle would be pi over 2 because we would divide pi into half and to get that one up there. And then if you really think about it, I've got 0 pi over 2, 1 pi over 2. Technically, pi is 2 pi over 2. So the one down on the bottom would be 3 pi over 2. 3 pi over 2. Okay, those are the quadrant angles, the ones that are actually on the x and y axis. Those are the ones that aren't really developed from the triangles specifically. All right, the ordered pairs that are there should actually be the easiest ones to do. Because if you think about this specific point on the circle, well, the radius of the circle, because it's a unit circle, is 1. So the radius means that I have gone in the x direction 1 unit. And we did not go up or down, so therefore the y value is 0. So that's your ordered pair right there on that point in the circle, 1, 0. If you were to go straight up, same general idea, I went straight up 1 unit. Well, that means I traveled 1 unit in the y direction, so the y value is 1, but I didn't go left or right, so the x value is 0. Same general idea going to the left. Oops, went a little too far. That ordered pair right there would be the ordered pair -1, 0, because we went 1 to the left and didn't move up or down, and then going all the way down. Oops, try and straighten that out a little bit. All the way down to that point. We went down 1 unit, so the y value is -1, and we did not go left or right, so the x value is 0. So we have those 4 specific ordered pairs. Everything else now is going to be done based upon those 30, 60, 90 right triangles. Let's start with the 45s. I think those are going to be the easiest ones to figure out. If we can think about it like this, 45 would hit right here. And the other 45, well, if you think about 45 as basically being halfway in between, that would hit right here on the top, and so on. So they're always going to be the ones that are hitting right in the center. So I'm going to do all my 45s in green. Kind of sketching those in there like that. If you think about what I just did, and you don't have to draw this part because it's going to get really messy if you try to draw this for everything, but I just took the whole top half of the circle and I cut it into 4 equal slices. Basically, think of them like slices of pizza or whatever you want to. So what I did was I took pi because that's the top half of the circle, and cut it into 4 equal pieces, which makes each one of these pieces right here pi divided by 4, or 1/4 of a pi. So the radian is pi fourths. Well, so now if I wanted 2 slices of pizza, that would be 2/4 of a pi. Well, 2/4 of a pi, 2 pi over 4, reduces to 1/2, or pi halves. So we don't have to include that one because we already have it. If I take another slice of pizza, that's going to be 3 pi over 4. 3 pi over 4. And then if I took another slice of a pizza, it would be 4 pi over 4. But 4 over 4 cancels out and reduces to just pi, so we don't have to write that. And then if you keep going all the way around the circle, the next one would be 5 pi over 4. Then 6 pi over 4 would be all the way at the bottom, but we don't have to do it because it's already done. And then 7 pi over 4 is out here. Okay, and there are going to be good ways to remember this, which I will talk about at a different time. But those are your pi fourths as far as radians. Now, we've already done the ordered pair on the previous pages, and that was the square root of 2 over 2 for both x and y. We already figured that part out. Well, again, if you use the idea of symmetry, this is exactly the same x distance and y distance away from the origin. It's just directionally different. For example, the one over here goes to the left and then up. And again, I'm going to erase that in just a second, but it's exactly the same distances. So they're both still the square root of 2 and square root of 2. I'm sorry, square root of 2 over 2 and square root of 2 over 2. The only difference is the x now has gone to the left, which makes the x value negative, but the y value still went up, so it's still positive. If you use that idea for the one in the lower left-hand corner, it's still square root of 2 over square root of 2, excuse me, I keep saying that, square root of 2 over 2 for both ordered pair, for both parts of the ordered pair, but it's in the left lower quadrant, which means everything is negative. So it's negative square root of 2 over 2, negative square root of 2 over 2. And then in the lower right-hand quadrant, it's still square root of 2 over 2, square root of 2 over 2, but this time it's the y value that's negative because it's down. So that's a negative y value. Try and write that a little bit neater. Negative square root of 2 over 2. There we go. And the x value is positive. Okay. And again, we have already developed the ordered pairs for the 30, 60, 90. So we'll write those in a second. But think about this. If we were to take this 30-degree angle right here, and we were to keep cutting this into equal slices of 30 degrees. Well, that's going to give me a 30, a 60, a 90 going straight up, this one out here, this one over here. I would basically have cut this into 6 equal pieces. Okay, I have 1, 2, 3, 4, 5, 6 equal pieces going around the top part of the circle, which means 30 degrees is the same thing as 1/6 of pi, or pi over 6. So if I wanted 2 of those, the 60-degree angle would be 2/6 of a pi, but 2 over 6 reduces to 1 over 3. So this is the same as pi over 3. All right, and so we're going to use some, again, we're going to use some symmetry here to figure out the rest of this stuff once we get to the ordered pairs. But the concept is, let's just keep adding 6, but let's make sure we reduce as we go. Well, the one at the very top would be 3 pi over 6, but again, 3 over 6 reduces to 1/2. It's already done for us because we already have pi halves, which makes the next one 4 pi over 6. But 4 pi over 6 also reduces because 4 over 6 reduces to 2 over 3. So that's 2 pi over 3. The next one would be 5 over 6. Well, 5 over 6 does not reduce. So that's good there. So the next one would be 6 over 6. Well, that's just 1, so that's pi. The next one will be 7 over 6. So 7 pi over 6. That does not reduce. 8 pi over 6 would be the next one around, but 8 over 6 does reduce to 4 over 3. The next one would be 5 pi over, sorry, not 5 pi. The next one would be 9 pi over 6. That's the one right down here at the bottom. We already have 9 over 6 because that reduces to 3 halves. The next one would be 10 pi over 6, but again, they're both even. 10 and 6 reduce. That's 5 pi over 3. And then the last one would be 11 pi over 6, which does not reduce. Okay, so the only other thing we haven't filled in is the degrees. That'll be the easiest part, believe it or not. We'll come back to that. All right, so let's fill in everything else that we need to know. We already have figured out the ordered pair for pi over 6. That was an x distance of, whoops, that was an x distance of the square root of 3 over 2 and a y distance of 1/2. And if you remember, the pi over 6, or excuse me, the 30 and the 60 are the same ordered pairs, just x and y's are flipped, they're changed, which makes this one 1/2 and then the square root of 3 over 2. So if you use symmetry, the same distance away from the x-axis is going to have exactly the same ordered pairs. So the one over here on the left where 5 pi over 6 is going to be the same thing as pi over 6, just that the x value will be negative. So we'll have a negative square root of 3 over 2 and a positive 1/2. And up at the top, once again, the x value is negative, so it's negative 1/2 positive square root of 3 over 2. All right, going down to the bottom, again, use symmetry. It's the same distances away from the x-axis, so this one is going to be the same as your 5 pi over 6 at 7 pi over 6, except both are going to be negative. So it's negative square root of 3 over 2, negative 1/2. And then the thirds are going to be negative 1/2, negative square root of 3 over 2. And then go into the fourth quadrant. It'll be positive 1/2 because x is positive there, negative square root of 3 over 2. And then at 11 pi over 6, it'll be square root of 3 over 2 and negative 1/2. Okay, so we filled out all the ordered pairs. The only thing we have left to do is do the degrees that match all of these. Well, if you think about your 45s, you're literally just counting by 45s all the way around the circle. And the 45s are the ones, again, that cut all these things in half at the top. So I've got pi force, which is 45 degrees. If I count another 45 degrees, that's 90. If I count another 45 degrees on top of that, that's 135, just adding 45 to 90. So let's do that in, I guess we'll do it in red. So that's 135 degrees there. Add another 45 degrees and you're at 180. Add another 45 degrees, you're at 225. Adding another 45, we're at 270. Add another 45 degrees, we are at 315. And then add another 45, we're all the way back around to 360. So we're just counting by 45s. I think the easier one for people to count by will be by 30s. So you got 30, 60, 90, keep going. Count by 30s, you're at 120. Count by 30, you're at 150. Count by 30, you're at 180. Add 30, you're at 210. Whoops, 210. Count by 30, you're at 240. Count by 30, you're at 270. Count by 30, we're at 300. And then count by 30 more, you are at 330. And then you get all the way back around to 360. So the biggest thing is eventually you guys are going to have to know, oh, 225 degrees is 5 pi over 4 in radians. Those things are going to become basic knowledge, hopefully, for everybody. But we'll get to how we're going to do that in a little bit. For now, that is how you develop the unit circle. So now we have all the degrees, all the radians, and all of the ordered pairs. Eventually, you will have to know all of these. Don't let that scare you. It's not that hard. It's just about pattern development. So as long as you can develop patterns, you're going to be fine. All right, plenty long enough for this video. Took a little bit longer than I thought, but that is the general idea of the unit circle.